Hello everyone, good afternoon. Welcome to the class ECE341, the probability and stochastic process. Today we will start the stochastic part. The statistic part. For statistic part, we will start from observe the sample value to do the calculation. Before today, we go over the probability theory. All the calculations is based on some probability or based on some distribution. Like you know the PDF, you do some calculation, or you know the probability of the sample space, you do some calculation, right? Now we have samples. We start from samples, not from the probability. Let's go to here. ECE341. This is the 11th week, Friday's class. Okay. So for statistics. So here I have something. The overall this part we need that. So like we have x. It is a random variable. X is random variable. Then take samples. I have x1, x2 until xn. And we suppose these x, they are independent. xi's, they are independent sample trail. Right? It's a sequence. Everyone they are sample of x. You can think every xi is also a random variable, has the same distribution of x. Okay. But they are independent of each other. So xi, xj are independent. If I do not equal to j. Alright, so suppose we have these. Then do some work, some calculation based on those samples x1 to xn. So this is statistics. Okay, then let's start the first problem for the statistics. So we say this is the point estimation. The problem is, suppose x has a distribution with an unknown parameter like C. Then we will try to estimate C. Yeah, the problem is just like this. Alright. Yeah. I have this. I put it here. Okay. So here's a problem. We want to estimate parameters of a random variable x by applying this method. Calculate. We have some values based on xi, and let this value as an approximate of e of x to the k. Yeah, this is moment, and x are the samples, right? Xi are samples of x. Then we want to estimate something. Here I have homework problems. So after the class, you will do these as a homework. Here we ask for A, B, C, D, F. I have 6 different problems, and each problems we want different parameter. In the first one, estimate the expectation value EX and the variance of X. So we want 2 parameters, EX and theta X, right? We do not know them. We'll try to find them. Do you remember the definition of EX? That is you have a formula, right? Calculate start from the like PDF or PMF, you can calculate. But now we will calculate based on the date, and the formula is just like this. All right. And the second one, we suppose X obey a uniform distribution. So this time is different with A. In A, we do not know anything about X. We just want to find the mean and variance. Second one, we know something. The the X obey a uniform distribution. But we still have something do not know. This A and B we do not know. We want to estimate this A and B. So you know part of the distribution of X. You know part of it, right? You know it is a uniform, but parameters don't know. Right? In A, usually do not know what it is. And okay, I have A, B, C, D, F, 6 cases. Like you look at E, problem E. We know X obey the Gaussian distribution, and we want to estimate the mu and sigma, right? So it is also the case. You know something about X. It is Gaussian, right? You know it is Gaussian. You know something, but in the Gaussian, you have a mu and sigma square. You do not know these two values. You need to estimate them. Okay, so all of these, they are typical problem for point estimation. So point here means a single value, a point. For a parameter, you want to know the value, a single value of that parameter. All right. Okay, this is a problem. And actually we need to explain something. Ready. Some problems in homework. So here I write here is try to understand the problem. Right? What is the problem? Yeah. In statistics, in most cases, the understand the problem is also part of the problem. Yeah, you need to understand problem first, then try to solve it. All right. So here you should know what is the problem. Okay. The problem is X has a distribution, but in the distribution you have some parameter unknown. Try to determine the parameter. Okay. And then we go back to the method. Moment method. Here, E x to the k. Let me see. You should explain the that is. I have textbook. Let me find. Oh no, just this will be which section, which chapter? Oh, I forget. Go to the back. Go to the front. Yeah, I want to show you where is it in the textbook. Parameter point estimation. Yeah, it's here. Point estimation of model parameter. Okay, this is this part. This is section 10.4. Okay, I put it on my notes. Okay, I put it in my notes. This is section 10.4. So actually here, you don't need to go over the other part of the textbook. You can just use my notes here, and then this section. Okay, 10.4. Yeah, they have a lot of things related, but here we just go to here. There we find the point estimator, point estimates of model parameters. Okay, then did you get the name? Oh, they go to next chapter. Okay, just like this. All right. So this is a. Let me go back here. So EX close to the mean value of n xk. We just use this. We use this. Just use this. This one is calculated based on the symbols, right? Based on the symbols. Oh, the formula is here. MK. This one. All right. Defined as 1 over n times x1k plus x2k until plus xn to k's. Okay, you see this one. Mn, mean of, this is the mean of xk from n symbols. Let me write it. Okay, so Mn of x to the k, it is this one. It's a mean of xk from n symbols. And we just let E of xk equal to this one. Now this one is a single value you can calculate, right? You can calculate. Then let this one equal to this one. Then you can solve. Say what is it? All right. Now let's go back to the AUT example. I still use that homework example. Okay. See the homework. See homework. You see the homework. Yeah, you see the homework. Here I have a homework problem. I take symbols. Now this one I take 10 symbols, and we want to find the following parameters. Right? Okay. Then we try to do it one by one, but you will work on this date, so I will choose some different date here in this class. Alright. Okay. Can I have both? Yeah. Example. Right. So X has symbols. I minus 1 as my symbols. Alright. Here is a 4. I use 3, 0, negative 1, negative 2, 0.5, 0.2, then 1.5, then 1, then 0.8, then 1.2. Okay. I use these as symbols. I have symbols. So A, we want to find estimate E of x and variance of x. Okay, this is a point estimation problem. I want two parameters. Estimate these two parameters, right? So this is a point estimator problem. Here, we do not need anything about the distribution of x. So this is the most, relaxed one. You don't need to know anything about x. So just to start from this symbols, find this one. And how to solve it? Actually, we already have this, right? In moment method, just use the mean value equal close to this expectation value. So ex, it is just close to m. Now it's 10. N is 10, right? I have 10 symbols. And x. Yeah, here's x, right? Here's x. This is x, just like this. So plug in. This one is 1 over n, n is 10 now. Then x1 plus until xn. K is 1, right? K is 1. So just the number, I do summation of all of these. 3 plus 0, then minus 1 minus 2, and then plus 0.5 plus 0.2 plus 1.5 plus 1 plus 0.8 plus 1.2. Alright, this one will be 1 over 10 times into summation of all of these is what? 3 minus 1 minus 2, they cancel, right? 0. 0.5, 0.2, I get 0.7. Then 1.5, 0.7 is 2.2. Okay, I can't remember. I just write down. And then 1 and the 0.8 is 1.8. 1.2, I get 113. Right? This is 3. Okay, this is 1 over 10 times 5.2. This is 0.52. We have EX. And the variance of X. We cannot use the moment directly. We need one more step. So we need EX squared firstly. Yeah. This close to M from 10 ensemble of X squared. So this is 1 over 10 and X squared. So X squared, they are 9, right? 9, then plus 1 plus 4 plus 0.25 plus 0.04, right? And plus 2.25 plus 1 plus 0.64, and this is 1 and 2 are 1.2, 1.2, and plus 1.44. Alright, and what it is? This is 1 over 10 times, okay, this is 14, like 10 and 4, 14.25. I check this for. And then this is 1, this is 2, I guess 3. 3.29. 3.29, right? 3.2 and 9. And these two I get 2.08. Okay, 2.08. Okay, this is 1 over 10 times. Okay, this one is 5 and 9 and 8. I have 14 and 2.2, right? 2.2. 2.2. I need 2 go forward. 2, and here's 2. And another 2 is 6. And then 2 and 3 and 4, these are 9. And just 1, right? Okay, so this is 1.962. We have EX squared. Then variance. What is variance? Variance of X will be E of X squared minus EX y squared. Now close to EX squared. I use this as a estimate, right? It's a 1.962. And minus EX. EX is a 0.52 with square. This one is, I need square of 5.2. Square of 5.2. Square of 5.2, I need to calculate. So for this kind of calculation, some calculator you can calculate directly. You just put in the date, then they can give you the whole average. Okay, this is a 1.962 minus 0.2704. Okay, let me minus solar. 1 minus 1.962. Yeah, I put the reverse way, so this should be positive. This is 1.6916. Okay, so we have variance. This is a estimation, right? This is estimation, approximate. So for the first problem, we have estimation E of x close to 0.52 and variance of x close to 1.6916. Okay, this is for A. Now let's go to second problem. Second problem, we suppose x obey a uniform distribution from A to B. We want to find A and B. Okay. Yeah, this is a problem, right? This is a problem. I want to find A and B. Now for uniform distribution, we want to know the formula of mean and variance related with A and B. So here you need to go to this one, appendix of the textbook. Appendix. We have appendix A. We have list of families of random variables, and we have the information about the mean and the variance. You see, the Bernoulli distribution. This is mean. This is variance. Now is a uniform, right? Uniform is a it will be continuous type. Also, Laplace maximum. Uniform. You see here, right? Uniform distribution and over the interval A to B. Then we have mean is A plus B over 2, and the variance is B minus A squared over 12. Okay, so we have EX equal to A plus B over 2, and the variance of X equal to B minus A over 12 with square. So here, this one close to what? We have EX is, we already have, this is 0.52, right? Yeah, we already finished A, so we can use this. If you try to solve this directly, do not have the part to find the estimation of these two, then you can just use the directly to calculate, to find that this is a M10 samples of X, right? And this one now close to 1.6916. Actually, this is close to mean with 10 samples of X squared minus mean with 10 samples of X with square. Now you do this calculation, you have this, right? This is what we did here. Okay, now you have two equations. A plus B over 2 equal to this number, and A minus B squared over 12 equal to this number. Then we can solve it. So we can have A plus B will be 2 of these is 1.04, right? A plus B. And the B minus A will be 12 times 1.6916 square root. Right? We have these. Here you have to pay attention here. Square root you get a positive value, right? Here B is large from A to B, so you need to put this B minus A, and here's a positive value. If you reverse, you write A minus B, then here will be negative. Okay, then we can solve it. I just let me give this value, 12 times 1.12 times 1.6916. Oh, it gave all the thing. Let me erase that. Can I erase that? I start using. So can I read? Anyone know? Or here? Okay, there's no history yet. So I need 12 times 1.6916 equal to is 20. Okay, it is a square root of 20.2992, and take square root. Should be 4. Okay, this is a 4.5. Okay, 4.5. I just keep close to 4.5. All right, 4.5. Then these two, to solve it, I do a summation. Then a can be cancelled, right? So it's 2b equal to summation of these two is 5.54. So b is 2.77, and a should be this one minus b, right? So 1.04 minus 2.77. This is a negative 1.73. Okay, this is a. B is this, A is this. Now this is estimation. We have two estimation about these two numbers. Alright. Does it make sense? The problem is here. X has symbols like this. And here we say it is a distribution from negative 1.72 to 2.77. So the possible result, the problem is here. The problem is here, right? Problem X is obey this one, and with uniform distribution, now we have these values. Put them together. Okay. So they are observed date, and we estimate it is a uniform distribution from negative 1.73 to 2.77. You compare these two, you can see it's not so good because you can have negative 2 here, right? You have negative 2, but with this one you cannot have negative 2. And largest value were 2.77. We have a 3 here, but along these you cannot have a 3. So this is just estimation. It's just estimation. Alright, this is A. This is B. Then we can consider next case C. Still use the same thing in the homework problem here. C is suppose, okay, still normal distribution, estimate B. But here I need different. So X obey a uniform distribution from negative 3 to B. We estimate B. Estimate B. Okay. Yeah, we suppose X. Let me turn off. I suppose X obey this one. We estimate B. Alright, we still use the formula. We use the mean close to moment with ensembles of X. Here we just need one is fine because I only have one parameter, right? So one equation will be enough. This one we already have the value. The formula is a negative 3 plus B, right, over 2. This is the EX, and close to this one is a point. This one I have it. This is this one, 0.52, right? 0.52. Okay. Okay, this time is simple. I have negative 3 plus B equal to 2 of it is 1.04, and B equal to 3 plus it, that will be 4.04. So X obey a uniform distribution from negative 3 to 4.04. Like this, right? Like this. B is this one, and A is given. is negative 3. So this is the second example. This one maybe make more sense, right? Our values, the most large one is 3, and the most smaller one is negative 2, and it's inside this interval, right? Inside this interval, from negative 3 to 4 to over 4. So it sounds better. Yeah, because we already have some information. Okay, this is a C and a D. Suppose x obey a exponential distribution E of lambda. We want to estimate lambda. Right. X obey an exponential distribution, and we want to estimate lambda. Okay, then you need to find the formula for exponential distribution. We still have it in the appendix here. It's uniform, so we need going up. Exponential Gaussian gamma. Okay, exponential is here. Yeah, exponential is here. So for exponential lambda, this is a PDF. Then here's EX is 1 over lambda. Okay, I just use this one will be fine. Let me copy it. EX equal to 1 over lambda. Alright. I have this, right? E of x will be 1 over lambda. And we know this is close to the mean value with n samples of x. Now I have 10 samples, and this value I calculate 0.52. Right, 0.52. So lambda equal to, that's it. It's 1 over 0.52. 1 over 0.52. So 1 over 0.52. Oh, you already calculated. Yeah, no. This is this one. Now is it right? It is a 1.92. Okay, I just put 2 letters, 2 digits after dot. It will be fine. Okay, 1.92. So we have lambda. So you see, understand how to do it? Yeah. So try to find this one and let it close to EX. And this formula depending on the distribution. You have a formula, you have this one. Then solve it, you have this parameter. Yeah, basically like this. And for some case, like for the Gaussian, things become simple. For Gaussian, E. Let me copy it. X obey the Gaussian normal distribution with mu, parameter mu and sigma square. We want to find mu and sigma square, or sigma. Okay, this problem is just sigma. We want to find sigma. Okay. Alright, so this is the problem. Looks like this. Here we have 2 parameters. Okay, so this is also the case. We need a 2 of it. We need a EX close to mn of x, the mean of n samples of x, and because I have 2 unknowns, I need one more equation. So x squared close to mean of n. Here's x squared. Right? We want this. So this one, EX is mu. EX is just mu. For normal distribution, EX is mu. So mu close to this one is 0.52. And EX squared, we know variance of x equal to EX squared, E of x squared minus square of EX. Right? So EX squared will be summation of these 2. Right? This one will be summation of these 2. So this one is a sigma squared. right? This is sigma squared. This is sigma squared. Sigma squared plus this will be mu squared, right? Ex is mu squared. Then this close to ex squared. Ex squared, I use this value, right? This is mn of x squared. This will be, we have calculated before, right? Yeah, we do the same thing. Yeah, this one. It is a 1.962. Okay, so we have equation, these two equations here. Then we try to solve it. We already have mu, and we don't need to solve. So mu is just 0.52. This is our estimation, and the sigma square is 1.962 minus mu square. This one minus mu square. This is a 1.962 minus square of 0.52. Yeah, not it. This one. So 962 minus, that is a mu square, is a 0.52 with a square, a square root. Oh no, can I read it? I can't do it. Anyway, no, it's wrong. It's wrong. I gave the square first. It's a 0.52, and the square. This is square, right? Oh, I just click that one. This is square. The point. Okay, let me write. This is a this one. Is minus square is a 0.2704, and this one, okay, this is 1.9 minus 2, I get 8, but I need to give one more to the 7, so this is 6, and this 6 I give 1 to here. I have 16 minus 7, I have 9. I have 9, and 2 minus 0 still 2, but I give 1 to the next 4, so it's this one. Okay, this is sigma square. This is sigma square. Sigma square. Alright, sigma square. So what do we ask for? Ask for sigma. Ask for sigma. So sigma is square root of 1.6916. Okay. So this is a 1.6916, and the square root is 1.3, just 1.3. Okay, 1.3, 0, 0, 0 something, 1.3. So we have our estimation here. Sigma is this one, mu is this one, sigma is this one. Okay, this is for problem E. Problem E. And then and the problem F, that will be similar. X now be a normal distribution, but what is the problem? Okay, suppose mu is given. Mu is given. Do I need the same mu? Okay, I can use the same mu. Suppose we already know mu. Then the only thing is we want to estimate sigma square. Sigma square. Alright. We want to estimate sigma square. The sigma square is, what do we want? The question is estimate sigma and the sigma square. Are both? Okay. Then find the sigma and the sigma square. Doesn't matter. We find one, then we have another one. Right? Yeah. Sigma square. Sigma square, it is a variance of x. So it is e of x squared minus ex squared. Right. So we need to calculate ex squared. this one is 1.962, right? This is EX squared minus EX. Okay, what is EX now? We know it is 2. So in this case, you do not need to calculate it, right? Here I have, this is EX. I use the estimate. I estimate it is 0.52. This is based on symbols. But now, suppose you already know the normal distribution, the given distribution, you already know mu is 2. Then you do not need to estimate, right? The estimate, actually this estimate is poor, it's not good. This 2, the difference is quite different. Then I minus, just use 2 squared. Just 2 squared. But here you will see the problem is that this is not good. You get this is with some negative value, right? Negative value. Some negative value. So, okay, this is a problem. Actually, the symbol is not good. Symbol is, this is a smaller than 0. Smaller than 0. Yeah, minus 4. So it's a negative 2.03a. Right, you get this one. It's smaller than this one. It's not good. So in this case, you cannot still use this family, this formula directly. You need to try this one. You think, by definition, this is a variance of x is e of x minus ex squared, right? This is definition. This is definition. This is definition. So we estimate by the definition. By definition, this will be e of, so e will be 1 over n, take average, you do summation, you have xi minus ex is 2, right? Ex is 2. Ex given is 2. Then square, you calculate by this way. Then this is a square, you know, you have square here. So this always give you a positive value. This one always give you a positive value. Now I have 10 values, right? So it is 1 over 10, square of each one minus 2. What are the data? Data are here. Data here. Data here. Each one minus 2 takes square. So 3 minus 2 takes square, it is 1. Then 0 minus 2 takes square, it is 4. 1, negative 1 minus 2 takes square. Okay. Negative 1 minus 2 takes square, that is 3 square. It's 9. And negative 2 minus 2 takes square, that is a 4 square, 16. And 0.5 minus 2 is 1.5 square, right? This one different with 2, this is 1.8 square. And this is a 0.5 square, right? And 1 square. And minus 2 is 1.2 square. And this is a 2 minus 1.2 is a 0.8 square. Alright. This can make sure we have a positive value, right? This is 14 and 14 plus 16, and this is 2.25, and this is 1.8 square. 1.8 square. Sorry, 1.8 square. Still, why it's always square root? 1.8 square. Oh, SQR here means square. No, square root. So what is 1.8? 1.8. If I put this one, it's what? Oh, SQR here means square. You know, in MATLAB, I use MATLAB, and also I think in C, SQR means square root. 1.8. Here SQR just square. They're confused. Okay, this is 3 3.24. Okay, yeah, 3.24. This is 1.8 square. I have these, and the 0.5 square is 0.25, and 1 is still 1, and 1.2 is 1.44, and the 0.8 is 0.64. Okay, so this is a 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let me combine this together. So this 2 is 30, and this 2 is 5.49, and this 2 is 1.25, and this 2 is 2.08. This is 1 over 10. I write it right here. It's a 30 plus 5.49 plus 1.25 plus 2.08. Right there. Yeah. Well, enter. I entered that. What? Nothing happened. I'm good. 30 plus 5.49 plus 1.25 plus 208. I have 38.82. So this is 3.882. Okay. This calculator looks not so easy to use it. They have some like a memory, some history. Wow, that makes things complex. Okay, so we have the variance, right? Now we have the variance, sigma squared. And after the battery is low. So I have sigma squared is 3.882, this estimation, and the sigma will be square root of it. Square root of these is 6.23. Yeah, 6.23 something. Okay, closed, approximately. All right. Yeah. So this is for the estimate with the last one. Suppose this one. So for this one, we cannot. The thing is, cannot use variance. Not variance with the EX square. Not yet. Cannot use EX square minus EX with square close to the variance, right? So to the equal to the variance. We cannot use this one. This is given. This is use M10x squared to estimate. And let me see. This is given. This will be sigma squared. We want to estimate. We cannot use this one. Oh, sorry. Yeah. So we have our result here, right? And for this problem, we cannot use this one. Because this will give us a negative value. Give us the negative value, so you can use it. But use E of x minus EX squared equal to variance of x. This is the sigma square we want to estimate, right? This is sigma square, want to estimate. And this one, I use M, I still, E I replace by the mean of 10 samples. And samples of what? Now is x minus 2. square. 2 is given, is the given value of EX. So this is a special case. When you estimate, if you just use that one, you get the wrong estimator. So you have to use this one. Alright, okay, that's all for today, and then see you next time. I have a little bit over. This is Friday, so have a good weekend. Bye bye.